the talk. My name is Gluchowski. I am from ZKsync, and I want to talk about how ZKsync is scaling Ethereum and what ZKsync is today. And at the core of ZKsync is this mission of advancing freedom for the world. We believe that freedom is the core thing, the key that unlocks innovation, that leads to progress, which creates prosperity. And to me, this is a very personal mission. Growing up, I was born in Soviet Union, which is known as the prison of nations. Experienced very, very firsthand the consequences of being unfree, like with hyperinflation, collapse of institutions, even going to school and just wasting 10 years doing things that I now absolutely would not have embraced in myself, and like it felt like really like prison, and my entire life growing up, it felt like I'm running uphill battle to finally start doing what I want to do and realize my potential. And I think this is how a lot of people feel. Like this is definitely the reality for most people in the world, and even in the Western world. And the blockchains are the one technology that actually has increased freedom by more than anything else in the last decade. And despite of all the abuses and all the excesses and the craziness that we see and the bad actors, I think it's done more good in the world than the bad. And scaling blockchains in a way that preserves these core properties that enable freedom, the censorship resistance, self-custodiality, permissionlessness, openness, is a hard problem. And this is why ZKsync started and how we jumped on this journey from a simple experimental ZK project towards building the first ZK VM, and to becoming the what we are today, the elastic network. Today ZKsync is not a single chain. It's a collection of many chains that are designed to work together in a seamless way. Like it's a roll-up cluster. You have some big names that you might recognize. You have Abstract. You have Exola, Lens, TreasureDAO, Kronos, Deutsche Bank, UBS, like the biggest financial institutions in the world are building on the ZKsync, or some of them are already live. And all of these chains are powered by ZK Stack, which is making them sovereign and configurable, which allows you as a builder to customize all aspects of your chain and have full control and sovereignty over what's happening there. You can decide what's happening with the sequencer. It can be centralized. It can be fully decentralized. You can have your own custom token for transaction fees, or you can accept stable coins or different kind of tokens. You can decide if then the chain is permissioned or permissionless, and to what degree. We can offer something very unique to ZK technology, which is privacy. The chains can be opaque from the outside world, and you control who sees the data. Like, basically, it gives you full sovereignty while preserving something very, very important, namely the connectivity and the ability to grow elastically, like expand without limits on throughput and growth for each individual chains and for all the chains combined. So the elastic network is a roll-up cluster. Roll-up cluster is this new, relatively new emerging concept that is not just a collection of chains. It's something more interesting. It's a architecture that is designed to make the chains seamlessly interoperable in a similar way how the internet works. I think by now it's obvious that as we are building the internet of value, this new iteration of the internet that will allow freedom of economic cooperation for all forms of value to go on chain. It cannot run on a single blockchain, just like the internet doesn't run on a single server or even on a single data center. we will have many different chains, many run by different communities, organizations, institutions, and even governments, but they have to be connected as seamlessly as internet is today, as the web is today. Because otherwise, you're going to lose the, it's not going to be internet. It's going to be just a collection of disparate services with siloed, it's going to resemble the finance 1.0. Like the banks are talking to each other with very, very high hurdles, and it's not seamless. It's not there is a lot of impediment in the existing financial system, and barriers and limits on freedom. What will define roll-up clusters ultimately is the ability for the users to interact with any applications across the entire roll-up cluster in a uniform way. Think of it as you have one wallet. You can connect to any application. Doesn't matter what chain the application is. You do one click, one confirmation, and you transact, and you do whatever you want. You want to do a swap on this chain, you just do a swap. You want to put funds into a DeFi protocol, you do that. You want to interact with a social network, you do that. Like all with one click very seamlessly. This is not the chain abstraction paradigm. This is very different from chain abstraction. Like the idea of chain abstraction is that you don't know which network you're on. Like it's all completely seamless, all fungible. You just see your balance across all chains. That is not what's happening here. Like individual chains can have very different properties, and you might want to trust some of these chains. You might not want to trust some others. So you want, like just on the internet, you can go to every website in one click and do whatever you want in one click. But the websites are different. They are run by different organizations. You might trust this web shop, but you don't trust this web shop, right? And your assets will, in this case, be like on one chain, like, or you actually control where the assets, where your account, your identity is located, and you can decide on this. But the interactions must be seamless. And this is the ultimate vision towards which we're working. And I want to explain how zero-knowledge proofs specifically enable this and why you cannot do it without zero-knowledge proofs. What zero-knowledge proofs enable is chains that can't be evil on a large scale. So it's the core feature that defines blockchains, that you can build something that can be evil. You go from this don't be evil to can be evil paradigm. This is how Bitcoin started. This is what Ethereum inherited from Bitcoin. If you run your full node and you don't trust everyone else, you verify all transactions, then the chain you're participating in cannot be evil. But this does not scale, because you cannot run the full nodes of thousands of chains individually on your laptop. It's just infeasible. Like you cannot, just like you don't run you can't run all the servers of the internet. And we're going to have much more than thousands of chains. Like if every single thing that touches value goes on Web3, on chain, we're talking about millions of transactions per second. I mean, the existing payment systems alone process between like 10, 100,000 TPS on some peak days, right? And if you add social interactions and micropayments and all the different kinds of, like, we're talking about massive volumes. No one can verify it directly unless you use some magic. And this magic is zero-knowledge proofs. Because ZK proofs, ZKsync ZK proofs, snarks, are essentially compressing computation. We can, like, I can take 1 million operations of 1 million transactions with lots of compute in parallel, produce proofs of different parts of it, recursively combine them into a single proof that can be verified on Ethereum, and then we can produce the proof of Ethereum blocks themselves and verify them on a mobile phone in less than 1 second. So you can turn every single mobile phone in the world in a full node of Ethereum that like fully verifies every single thing that happens on all of those thousands of chains. So like making all of them chains that cannot be evil, at least with respect to the promises they make, to the commitments they make. So of course they, like, if they say, this is a permission chain. It's not a rollup. It's a Validium. We hold data in our own servers. Then, of course, they can like shut down access to those servers. So they can be evil individually towards you, so you have to decide whether you trust them or not. But they cannot be evil with respect to each other. Like if they define some communication protocol, some interaction protocol between them, where like I pass a message, this message is produced by this system contracts, the system contracts are uniform, they are all the same on all these chains, then there is no way for them to fake this message. Sure, they can shut down and disconnect, but they cannot fake it. And this, in turn, enables things like shared bridge. And this is a very interesting concept. So, like, imagine that you have two different banks, and you have gold in each bank, and you have customers who want to transact. So, like, customer from bank 1 wants to send gold to a customer from bank 2. How do they do this? Well, like, the simple way they could instruct the bank to send the gold, which will be very expensive because you need to transport it over the land, you need to pay insurance, you need to secure it. Like it's quite a heavy operation. So an alternative could be you just like make a note that bank 1 still keeps the gold, but they owe this gold to the bank 2. So as long as the banks can trust each other, you can just do like a single operation on paper, and then it would work. And this is roughly how it works today with traditional bridges. Like you rely on maybe there is some third party who both of these banks trust for keeping these records correct, and they just move the records, but the gold never leaves the two storages. But this introduces this trust assumption. As you scale the system, as you add more and more banks and more customers and more intermediaries, the trust does not extend to all of them. Like you cannot trust all of them. And so like you introduce inefficiencies because there is this web of trust that does not expand. So if we only could make banks like magically trust each other, what we could do is take one single storage, like let's call it like a magical Fort Knox, where all of the gold of all of these banks is stored in one place, and then the banks keep the records, and they are kept by, I don't know, like magic dwarfs that cannot be evil and never fail to execute consciously the keeping the records and updating the records. Then any customer can interact with any other customer at random scale. You know, you can add banks, keep adding banks to the system, keep updating the records, and it's going to be very, very cheap because it's like you don't have to transfer physically gold between those subsidiaries. And this is what's happening with rollup clusters, with this idea of the shared bridge. ZK enables chains that can be evil, and chains that cannot be evil to each other enable this architecture with the shared bridge and Merkleized commitments of individual chains that can update the records succinctly, like on each side. All of them are ZK proven, so like they are not only computationally honest, keep computational integrity to each other, but also to the customers. And this enables this infinite, fully elastic network that can grow without limits, and that can actually absorb like all of the financial or non-financial value transaction of the world. And this is what the elastic network is. So this is a longer-term vision. This year, we're focusing. We have published this roadmap from Matter Labs, and at the end of the last year, we're going to stick to it. The priorities within the roadmap are dictated by the needs of individual chains. Like for us, the highest priority for Matter Labs is the success of partners of builders who are building on the Elastic Network. So we're talking to them very closely, like understanding what they need to prioritize. Right now, the absolute priority is shipping the EVM bytecode equivalence, which is coming very soon to all ZK stack chains. And after that, we're going to be increasing the throughput of chains. The estimate is we think it's realistic to get to 10,000 transactions, transfers, average ERC20 transfer transactions per second, at roughly 0.01 cent computational proving costs for these transactions. Getting to stage 1 for security of the chains, potentially even stage 2. Like stage 2 is realistic this year. I don't want to commit to that, but stage 1 is on the commitment list. improving the user experience and working towards this vision where every user can connect to every chain and just interact with one click. And doing something very, very important for financial institutions in particular. And as I mentioned before, we have some of the world's largest banks like Deutsche Bank and UBS building on experimenting with the Elastic Network specifically because they need privacy. Like, it's inconceivable for the world to get to mass adoption of blockchains if every single transaction, every single wallet is completely transparent for the entire world. Like, that's just not going to work. I think it should be obvious to everyone by this time. And then finally making the connectivity between these chains full reality, including the private chains. Like, two banks can be operating their own closed private validiums. They can still talk to each other seamlessly and send funds without anyone from the outside world seeing what's happening. And they not having to trust each other with fully atomic composable transactions happening on this private separate networks. ERA, the first chain in the Elastic Network, this original first ZKVM, is going to continue play a major role in the Elastic Network rollup cluster as the hub for liquidity and integrations with major infrastructure providers. And if you have followed the, ZKsync governance has introduced a ZKsync Ignite program for boosting the TVL of ERA and boosting capital efficiency of DeFi operations on ERA last year, and it's been a major success so far. So I encourage you to explore this. There is a beautiful website where you can see what rewards you can get for liquidity incentives. And then I also want to introduce two major initiatives that are coming to ZKsync very soon. One is the new community program kicked off by governance with 5 million ZK tokens for engagement and support of the community. And it's going to be expanded with local teams working in different parts of the world who understand their local geographic regions and cultures way better than you can do from a single place. They're all going to be part of this program, and I encourage you to join us today and tomorrow at the Elastic House, which is a big community gathering of ZKsync, where you can learn more about these programs, ask us any questions about the roadmap, the mission of ZKsync, and can get connected to fellow builders. And with that, that's it for my presentation. Thank you very much. Happy to take questions if there are any. No questions? OK, thank you.